Okay, this is Algebra 1, Lesson 7.3. Today we're going to look at multiplication properties of exponents. So let's do our warm-up first. So make sure you guys have done the warm-up before you just watch me do it. Okay, so number one, it wants us to write each expression using an exponent. So what we're going to do is we're going to look at what's repeated. Well, this base of 2 is repeated 3 times. So that means we're going to write a base of 2 raised to the third power since it's multiplied by itself 3 times. In number 2, our base is x, and it's multiplied by itself 4 times. In the next one, in our denominator, it's a base of 4 raised to the second power. If I had told you to write this with a negative exponent, to make it a negative exponent, you would bring this up to the top and write it as 4 to the negative 2. However, I know that we said we don't want negative exponents, so it's probably best to just leave this as 1 over 4 squared. Okay, so now we're going to write each expression using the expanded form, so the factored form without exponents. So our base is 4, and it's being multiplied by itself 3 times. So 4 times 4 times 4. In the next one, y is our base, and it's being multiplied by itself 2 times. So y times y. In the next one, let's rewrite this to get rid of the negative sign. We're going to put 1 over m to the 4th. That makes our exponent positive now. And now our base of m is multiplied by itself 4 times. So we still have to keep the m in the denominator. It's just multiplied by itself 4 times. Okay? So today we're going to look at using multiplication properties of exponents to evaluate and simplify expressions. You have seen that exponential expressions are useful when writing very small or very large numbers. So we did that yesterday with scientific notation. To perform operations on these numbers, you can use properties of exponents. You can also use these properties to simplify your answer. In the lesson, we're going to learn some properties that are helpful for you to simplify these exponential expressions containing multiplication. So an exponential expression is completely simplified as long as it satisfies all of the following bullets. And there's a lot here, so you have to always check. There's no negative exponents. The same base does not appear more than once. And remember, your base is, like if we had it like this is our base. No powers are raised to powers. So it's not like x to the 4th raised to the 3rd power. You can't have that. And then no quotient or no products are raised to powers, and no quotients are raised to powers. Okay, and then numerical coefficients in a quotient do not have any common factor other than 1. So these are some examples of simplified expressions. So everything is simplified. These are not examples. So in this one, we have a negative exponent. That can't be. In this one, we have a repeating base. In this one, we have a power to another power. In this one, we have multiplication raised to a power. We have a quotient raised to a power. In this one, we can simplify here, and then so we don't have our simplified coefficient out in front. We're going to look at how to do all this. Okay, so products of powers with the same base can be found by writing each power as a repeated multiplication. So for example, 3 to the 5th can be written as 3 times 3 times 3 times 3 times 3. 3 to the 2nd can be written as 3 times 3. So if you count, we've got a total of 7 3's here. So we can rewrite this as 3 to the 7th. Notice that the relationship between the exponents and the factors is that we're adding the exponents together. So if you see multiplying of the same base, so we have the same base multiplied together, you are to add the exponents. Let me go back to this example. So here's another example. If I have the same base, 6 to the 7th times 6 to the 4th, we're adding the exponents, so our answer is 6 to the 11th. So it's as long as the bases are the same and they're being multiplied together, we add the exponents. So let's try an example. So we've got a base of 3 that's the same. So we're going to add our exponents, 2 plus 5. So that equals 3 to the 7th. In this one, the ones that have the same bases are right here. So we've got 2 to the 4th and 2 to the negative 2nd. Well, 4 minus 2, okay, 4 minus 2 equals 2. So our base 2 is going to have a 2 times our base 3 now. We're going to add the 4 and the 2. We've got a base of 3. 4 plus 2, sorry guys, is 6. So our answer is 2 to the 2nd times 3 to the 6th. Okay, so now we're going to simplify without actually having any numbers here. So we find the common base. Our q has a common base, and we're going to add the exponents, 3 and 6, so that becomes q to the 9th times r to the 2nd, and you're done. In the next one, we've got 3 minus 4, and then it's implied to have a 1 up here, so 3 minus 4 plus 1 is equal to 0. So n to the 0 is actually 1 as long as n is a non-zero, non-negative number. A number or variable written without an exponent actually has an exponent of 1. So that's kind of what I did on the last one. Even though the n didn't have a 1 written here, it's implied to just have a 1. So 10 is the same thing as 10 to the first. X is the same thing as x to the first. 3 is the same thing as 3 to the first. So you can always write it like that if you need to. All right, so now we have an application problem. Light from the sun travels at 1.86 times 10 to the 5th miles per second. It takes about 15,000 seconds for the light to reach Neptune. Find the approximate distance from the sun to Neptune. Write your answer in scientific notation. So they're telling us that distance is equal to rate times time. Well, our rate is 1.86 times 10 to the 5th, and our time is 15,000 seconds. Okay, we're going to rewrite this in scientific notation so that all the parts have scientific notation. So 1.86 times 10 to the 5th. We need to rewrite this in scientific notation. Well, let's look. Where is our decimal place on this? It's over here, even though we're not writing it, and we're going to move it to the left. 1, 2, 3, 4. So it's going to be 1.5 times 10 to the 4th power. It's a positive 4 because the original number is bigger than 1. Now I'm going to combine like term or like numbers. So 1.86 times 1.85. And then I'm going to combine these because they have the same base. So 10 to the 5th times 10 to the 4th. Now I wouldn't expect you to be able to do 1.86 times 1.5 in your head, but just so you know, it comes out to 2.79 times 10. Now because these have a common base, we can just add our exponents, so 10 to the 9th. And we need units on our answer, and since our original rate was in miles per second and our time was in seconds, our seconds are going to cancel, and we're left with miles. So again, all we did was we wrote the 15,000 in scientific notation. I regrouped my numbers, so I grouped the 1.86 and the 1.5 together, and then I grouped the 10 to the 5th and the 10 to the 4th together, and then I added exponents since they had the same base. So to find a power of a power, you can use the meaning of exponent. So if I have 4 to the 3rd and then that to the 2nd power, that is like 4 to the 3rd times 4 to the 3rd, which all you're doing is adding those together, those exponents, and getting 4 to the 6th. But an easier way to know it is that when you have a power raised to a power, you're actually just multiplying the exponents. So this is different than if I had 4 to the 3rd times 4 to the 2nd. That's very different than 4 to the 3rd raised to the 2nd power, because in this case I would add the exponents and get 4 to the 5th. In this case I would multiply the exponents and get 4 to the 6th. So those are your two different rules you have to be careful about. So when a power is raised to another power, we multiply the exponents together. So 6 to the 7th to the 4th power, we take 7 times 4 and get 6 to the 28th power. So here we have a 5 to the 2nd raised to the 4th power, so we're going to multiply our powers. 2 times 4 is 8, so we have 5 to the 8th. Obviously, I wouldn't expect you to carry, you could take 5 times 5 times 5, 8 times and find the actual number, but since you don't have a calculator, I'm not expecting you to do that. 3 times 0, that becomes 4 to the 0 power. Anything to the 0 power is just 1. Okay, so we're going to take this step by step. We're going to multiply this first, and that becomes x to the negative 15th power times x to the 4th power. We still have that. Now, since we have a base that is the same, we're going to add our exponents. Well, negative 15 plus 4 is a negative 11, And we don't want to have any negative exponents, so we're going to move that down to the denominator as 1 over x to the 11th. And then powers of products can be found by using the meaning of an exponent. So if I have 8x all raised to the third power, you have to make sure that you take that power to everything inside of the parentheses, because it's 8x times 8x times 8x. So you're going to have 8 cubed times x cubed, which is a 512 x to the third. So a product raised to a power equals the product of each factor raised to that power. So you have to take everything inside of the parentheses. You can't just take what's right before it. So for example, if I have 2y squared, so that's what's in parentheses, I'm going to do 2 times 2 and y times y. So my answer is going to be negative 4y squared, because the negative is out in front. In this case, it's going to be negative 2y times negative 2y times negative 2y. So a negative times negative times a negative is a negative. 2 times 2 times 2 is 8, and then I have y to the third. So make sure if it's in parentheses, you're doing everything inside. Okay, so for this next one, we're going to make sure that we apply it to everything inside. So it's going to be x to the 6th times x to the 6th times y to the negative third times y to the negative third. Now I can add my exponents, so that's x to the 12th. Negative 3 and negative 3 becomes negative 6. And because I want this to be a positive exponent, I'm going to move that into the denominator. So I'm going to have x to the 12th over y to the 6th. And you're done. Okay, so if you want more practice, go ahead and pause this video and try these right now. I'm going to walk you through them just for more practice. I highly suggest you do them just to make sure you know what you're doing. And then if you don't understand what I'm doing, bring your questions to class. Okay, so we're going to simplify. With this first one, it has the same base and we're multiplying, so we're going to add exponents. So that's 3 to the 6th. This one, because it's a power to a power, we're going to multiply exponents. So 3 times 2 is 6, so that's x to the 6th. In this case, we've got to make sure we apply it to everything inside. So it's going to be 5 cubed and g cubed. 5 cubed is 125, and then g cubed. Okay, on this next one, I'm going to distribute this first. So that's going to give me x to the 6th and y to the 3rd. Times, I'm going to distribute this now, x to the negative 6th and y to the negative 4th. Now I'm going to combine my like exponent, the ones with the same base. So 6 minus 6 becomes x to the 0. 3 minus 6 becomes y to the negative 3rd. Did I do that right? Did I miss something? Oh, this is to the negative 4th. Sorry about that. Because negative 2 times 2 is negative 4. So 3 minus 4 becomes negative 1. Now this x to the 0 becomes 1. So I have 1 times y to the negative 1. But I want that negative 1 power to be positive, so I'm going to put 1 over y to the first. And that is your answer. Okay, with this next one, we've got the same base. So we're going to add exponents. And remember, if it's not written, this is just a 1 there. So 4 minus 2 is 2. Plus 1 is 3, so we've got z to the 3rd. On this next one, I'm going to multiply it through, so I've got to carry the negative with it. Negative t to the negative 15. Well, to make this negative exponent positive, I'm going to move it into the denominator. So I've got negative 1 over t to the 15. Now make sure when you move this down, it's only making the exponent positive. It's not changing this negative out in front. You still got to keep that with the number. It's only making the exponent positive. Okay, so now we're going to have negative 3 squared. So that's negative 3 times negative 3. And then that equals, negative 3 times negative 3 is positive 9. And then the negative 4 times 2 is f to the negative 8. Well, we want that to be a positive exponent, so we're going to move the f to the negative 8 into the denominator and get 9 over f to the 8. And that is all.